This class week 12, and I hope one more class I will take week 13 next Monday. That is an extra class. So that in that class I will cover basic of wastewater treatment based on not the activated sludge one, but I will cover the other technologies, membrane and thermal based technologies, like you guys we have already discussed RO, FO, and these kinds also with electrodialysis and thermal based technology. These all I will just give a flash, note, and then some of the doubts from the starting of the lecture. I will cover that also in the 13, which is in Monday. So that is an extra class actually. We have only 12-week assignments and 12-week class, but I will we can take one more class. So we'll start this week 13, week 12. So the first question, match the, this is actually theory based. Like I think the last class is also relatively, there was no problems. It was purely theoretical. So now we'll start. First question, match the different aspects of wastewater recycling project given in the column. So here there is different, like according to the wastewater recycling, there is different aspects are given. You have to match with the B column. First one, technical aspects, financial, social, and environment. So you can match with the on the basis of investment, impact on ecosystem, and then if reliable and efficient the whole system setup, and public acceptance. What do you think? Like there are four options given. What do you guys think, which one would be more right? So okay, then if when you think about technical aspects, then you see technical aspects mean the whole, the setup of the plant for water recycling and all. Accordingly you can think of. So technical aspect, you see, compared to this four option, this one you can see selection of reliable and efficient treatment system. That is the technical aspect. The how, what treatment technology you will give, and what is the capacity, and what is the quantity of the water that need to be treated per day, and what is the physical and chemical properties of the water. So this is technical aspect. So one will come here. Financial aspect, what do you think? Financial. So financial means here it will come for this option, ensuring benefit exceeds over the planned investment. So even this wastewater treatment is also a big business, right? Even if you start a plant, there should be some profit even after running cost and maintenance cost. Apart from these, you should have a profit from the treatment plant. Then only that can stay for longer, right? Otherwise if you don't get that much profit, then there is no point in also starting a wastewater plant. Because even if a big companies, private companies also coming to build wastewater treatment plants for their profit, but in a way that it is benefiting us also. So financial thing, like we should have a planned investment first. Then with the investment, you should have the maintenance cost, and how what is the capacity and all, and you should get the profit after a certain period. Then what is about the social aspects? Social aspects means it's ensuring the public acceptance. Why? Because in many, in our country also, you see that water, if you take from the well, or if you get from what if you get from desalination plant, or uh, something like that, you are fine. Like people accept, they don't have any problem in drinking. But when you think about wastewater, like wastewater industry, like wastewater, that treated water, many people think that it is um, not to be consumed. So there should be a public acceptance to for a win, if you want to win this in wastewater recycling uh, sector. Then environmental aspects means here ensuring overall positive impact on the ecosystem. So this is like you're treating wastewater, so you're not disposing the wastewater directly to the land or in the water, so that the ecosystem is preserved, and you extract the maximum minerals, and you can decrease the amount of chemicals inside, and then you can dispose. So there is an ecosystem balance can also happen with the wastewater recycling. So these all things you can find out, and this correct answer for this is C. Okay, next question. The major hurdle in wastewater recycling is, so options are unavailability of suitable technologies, political motivations and social acceptability, C, abundance of freshwater resources, D, none of the above. Any answer? Sorry, which one? No, it's not option D, it's B. Political motivations and social acceptability, because when we compare other option, you see there are see in, if you have a good policies in India, uh, this it was easy to achieve this wastewater recycling, and also social acceptability. So many people, I think more than 50 percentage of people in India thinks that this wastewater treat, like the water which is generated after this treatment of waste, is not consumed. So they have some religious thing, or so they don't accept. So that is the important thing. Also the political, we should have a strong policy, strong laws. So we are lack of these things. We have a very good technologies. We It's already well established technologies are there, and also there are developing technologies are there to treat the wastewater, and that in that the zero liquid discharge is there. So even the zero liquid discharge in some part of India it is started. Okay, but people are not ready to consume the water from wastewater treated plants. Okay, next question. The fit for purpose water treatment. So this term fit for purpose, so here fit for purpose wastewater treatment is a process that considers the intended use of water in the environment, the economy, to treat the wastewater. The goal is to treat wastewater to right quality without over or under treating. What do you think? Over treating. Anyone say over treating? So what do you mean by over treating a water? So over treating means, you see, water is extremely pure. It's deionized water. For example, I'm saying in deionized water, its conductivity of deionized water it's very low, or we can just approximate also it's near to zero. So that means the elements are not present. So even for for the human consumption, there should be a proper elements should be there in the water, so that will benefit for our our body. So di water means it's completely pure, there is no other mineral elements presence. so this is the di water. That means if you over treat the water, if you treat the water to completely remove all the minerals, so all the elements from that, then it will reach near to di water. What we need is our water consumable. If this consumable level is here, this is the consumable level, and if you treat again then it become di, then if you treat less then it is under treat. So this we can't consume the water here. Then this, when we reach our treatment technology or treatment system to treat our water to a particular level for consumable, that is consumable. And again the water, if you treat again, then it will become completely very highly pure water, which is, there are a lot of elements which is not present there, which is needed for our body. So that is the over treated water. So now fit for purpose means it's that considered intended use of water. Treat the wastewater. Here the water should be treated in a proper way. It should not be under treated or it should not be over treated. That depends on the application also, where you want to apply the treated water. So here there are four options given. Fit for purpose wastewater treatment. A is environmentally sustainable but economically inefficient. B, the degree of treatment is decided based on the intended end use of reclaimed water. C, avoids wastewater treatment for saving the coast. D, all of these. What do you think of the fit for purpose wastewater treatment? Any answer? B. Yes, B is the right answer. So what do you so B is the right answer. So why this is like, you should know the end use of water, then you decide how much treatment you need. So for what this DI water is useful? So in industries for the fabrication, so in some of the industries, so if you want to fabricate, for example, if you want to fabricate very, membranes even for the for dialysis or something, like very, very sophisticated membranes you want to fabricate, in some of the step you have to use DI water, not the, RO water also. So during the fabrication pathway, so like that there are different applications where you need DI water. So there you need to treat that much. So if you want to consume, you don't need to treat that much like DI, then it is fine. Undertreated means, if it's a little bit undertreated, then it is not human consumable, but if you can use for the agriculture, you can use it. So like that you decide the end use where you want to apply, then you decide that how much treatment I should give for the wastewater. Next is fourth question. A decision support system DSS for wastewater management is typically helpful in. Four options are given: selection of appropriate treatment units, B, sequencing of units for treatment plant, C, identifying recycling or reuse options, all of the above. A decision support system for wastewater management. What do you think? Any option? So answer is D, all the above. See, decision support system for wastewater management. So you should select the appropriate treatment units. So sequencing of units for the treatment plant. So like how many units you need for example, I'm saying you need to treat see wastewater from dye industries, or then this is wastewater from dye industries. Then you have wastewater from oil and gas industry. So you will select the technology, then you go for a technology, you select for this oil and gas which one is most suitable, and for the dye industry which technology you can go. That depends on the chemical composition of the wastewater also. Then you have to treat how much you need, like I mean, like if you go for a thermal method, a thermal treatment method, there is maybe you may heard of MSF and MED, multi-stage flash distillation, multi-effect distillation. So these are thermal based technologies. So this is like it's a kind of chamber by chamber it will go. So if we put the wastewater, then there is some vapor generated, it will collect, then again the remaining wastewater will go to second chamber, like that. So like this you should know, like how big you want, or how many different compartments you need for this MED and MSF. This type of chambers are there. Or if you go for the electrodialysis, so electrodialysis, we have already discussed. Ion exchange membranes are there, anion exchange membrane, then cation exchange membrane. So then this become one like compartment. So like that you can stack more. So it number of this will depend on the concentration, also the amount of water you have to treat. Then identifying recycling or reuse options. Like before that, if you don't want to treat also, like if you want to treat recycle, you can recycle. And also you can, if the water which is treated from any of these technologies, even MSF and MED, the vapor is somewhat pure, and the wastewater which you get in the end stage, even you have some concentrated one, that if you can also use this. If it's more concentrated, then it is more rich in minerals or some of the elements, so that one you can use for the resource recovery also. Okay, so a decision support system for wastewater management will include all these steps. So here you can read. So the what this wastewater treatment plant decision support system, that system that help with the design and operation of the wastewater plants, and face many complex objectives such as minimizing cost while ensuring safe and reliable wastewater treatment. Then can help with by integrating cause effect relationship and representing knowledge in a way that enable comprehensive reasoning. So here one more thing is there, cost, how this cost affects cost, minimizing cost. So for example, if you have an oil industry here, this is an oil industry. So if you want to treat this uh, away from your plant, then you need to transport. So that for that you use transportation pipes and all pipe system. Then you have a plant. So the cost, if you have when you calculate the cost, here it will come, this is the treatment plant. When you analyze this cost, you have to give also this transportation cost. Transportation cost is also a big thing in many of the treatment plants. You may also heard of backwater treatment plants. So in that backwater treatment plants, mostly in Rajasthan, which is landlocked region. So there, you transportation cost, when you get a concentration one, then how do you can't dispose also, there is no sea nearby. So there it is much more difficult. So here you see transportation cost is an important thing. Then you should have the planned build, like a whole plant setup. Then also this also it will come, labor cost also will be there, and then labor cost and then maintenance cost you can add. Labor cost. Then also you need electricity. So electricity I'm not adding, but even in the maintenance, not in the maintenance, maybe in the plant setup also you can add electricity also. Electricity also it's important thing. So you have to understand like how much cost is needed for a plant setup, and how in what step you can minimize or optimize the cost so that the total cost is less. And also you may heard of one more thing. If you set up a plant here in one place, that a particular place may have another setup. I mean, like maybe it is a full of plants, or it's a trees or some other buildings. You have to first remove all these and then you have to build. So clearing the land also is a big thing. So you finding a land and clearing the land, that is also big cost. So these all cost will come when you fully analyze the water treatment plant setup. Next question: which of the following statements are true? Higher cost is incurred in wastewater reuse and recycling. B. Nutrient management is crucial for the success of wastewater recycling. 3. Biosolids do not have any useful reuse applications. So, what is the which are the statements are true? Any guess? Any idea? Answer is A. Statement 1 and 2 are true. Higher cost is incurred in wastewater reuse and recycling. Then nutrient management is a crucial for success of wastewater recycling. Okay. Next question. Public acceptance for recycled water can be enhanced by. Four options are given: public awareness campaigns involving media and women, B. Providing subsidies on using recycling water, C. Promoting through demonstrative projects and models, D. All of the above. How do you increase the acceptance of recycled water? Yes, D. Yes, yes, right. So D is the answer, because all these things are needed to increase the acceptance. Public awareness needed. You need to give some subsidies for using recycled water, and then promoting through demonstrative projects and models. Next question. The several incidents of public protest against wastewater recycling scheme were mainly due to of unfair distribution of recycled wastewater. We discussed about idea of using wastewater. C. Higher tariff of recycled water. D. All of the above. Several incidents of public protest against wastewater recycling scheme were mainly due to which of the following option? Any answer? Yes, right. It is B. Discussed about the idea of using wastewater, that is yuck factor. Here you I will just explain. See, here in this figure, you see that this is a very good, nicely prepared soup. Imagine the same soup, it is stirred by a used, it is used but it is washed, it is cleaned with water, or it is cleared, but still there is a comb, you just stir it. Then how much do you like? So there is a campaign like from dislike means 1, then when it is 5 means it's neutral, then 10 means like extremely. So this is a survey type, like you can conduct and find the, from different people, then you can even tell. So you guys, I think how many people are there? I think today 4 people are there. So can you just message here only in this message box from this here, from this yuck factor survey. So what you guys, from 1 to 10, which number do you choose? Imagine this is a nicely prepared soup, and then it is stirred by a washed comb. It is cleared comb, it's washed comb, but still you're stirring with the comb. What do you think? Oh, do you like the soup? And according to your likes, can you just message in the, in this can you just message in this which number you choose? You can just put a number. Okay, Sanjay 1. Yes, lowest one is 1, you can see here. Lowest is 1 means extremely you dislike. Then when you reach 5, then it's neutral. Then 10 means it's like not even, no, extra 10 means very, you are fine, you're okay. Okay, Sankamitra 1, then Pooja 9. Okay, okay, okay. Yeah, many people, like even when we see this now, like we don't like. Okay. So any comments you want to just say? Sangamitra, you want to add something? Okay, okay, okay. Then Pooja, you can add something. Hmm. Hmm. Yeah. Yes, yes. That's, we actually think of it like when we see it, we don't. You may don't feel to drink or consume. Yes, you're right. Then Pooja, what you gave 9. Okay. Then Sanjay, you have anything to add? Okay. Okay, so uh, even you guys know that in space how it is recycling of water is happening. So in space also, see, even even the urine also they are recycling and they are taking for the drinking, because there is no other way of drinking, right? So I just type space recycling. So you see that if you see, even if you search in the net, you'll get a lot of documentaries on this, how they are not even wasting a single amount of water, because there is no other way of drinking. So if you search, you will get. But even when we are like, since we get enough water to drink from nearby, then we don't feel also good to drink, which is even as you see, like, if something, you see also your food is in touch with something, we don't feel to drink or eat. That is true, but in some situations when the water is going to, now the because of the climate change, there are a lot of, in some areas it is drought, in some areas it is heavy rain. So at a particular time we also need to adapt. For that time I feel like we all will adapt this, and then we also start drinking, like, even treated wastewater also, because we don't have any other source that time. Okay, then you can just google it, or just go through some of the documentaries, you will get to know. Okay, now next question. New water of Singapore recycles water for, um, four options are given: industry, augmenting or domestic water supplies, both A and B, neither A or B. What do you think? New water of Singapore. Answer is C. Both A and B. Industrial application, also augmenting domestic water supply, depending on the end composition of the new water, then it can go either to industry or for domestic water supplies. So here, actually, this new water, it's a, it's a very famous name nowadays, because when you go for some water conferences and all, there is a few talks on this new water most of time. So this new water is a brand name given to highly treated, reclaimed wastewater produced by Singapore Public Utilities Board. So this, you may had heard of, like, so which water do you consume? There is somewhat debate, like, new water is good, or do you consume potable water? So there was some talk in previous, I think, previous um, year. So here you can see Singapore is known for innovative approach to water management, and particularly its effects in water recycling and desalination. So here, this country, Singapore, has few strategies. You can see rainwater harvesting, imported water, new water, and desalinated water. Also, you have think of, see, we in some of the countries, this water, water level is very less, so that they have to find new technologies, either to extract water from waste, or some, they can buy water, or some way they have to get water. So they are even developing new technologies, like, even we in our country, I don't know, like, how many efficient rainwater harvesting systems are there. There are a lot of areas where they do rainwater harvesting, but not every. And also, in Singapore, see, imported water is also there. And then new water, it is a highly treated wastewater that is used for industry purpose and can be used for drinking. And then desalinated water, that water which is converted from seawater, this is, people will accept this desalinated water. Most people will not be accept, because it's a water from sea, and then they are desalinating, and then using for drinking. New water means it is mostly for industry, because it's very treated water, that means very pure. So it can go for industrial purpose mostly. And then importing and rainwater harvesting. And also this water, water, we can, there are technologies, you can take water from air. Anyone heard of this thing, water from air? Just search for this also, like you can actually take water from air. Air means your surrounding atmosphere. So now how they are doing this new water, means how they are extracting this highly treated water. First step, this is for new water, how they are producing new water. New water, right? No. First step is microfiltration or ultrafiltration. Typically, first stage of new water production is microfiltration or ultrafiltration, in which process the treated wastewater is passed through membrane to filter out microscopic particles and bacteria. Okay, that is the first process. Then you can see second process is the reverse osmosis. So in reverse osmosis, it is the second stage of new water production. And then here the semi-permeable membrane with very small pores are used. This allows water molecules to pass through while leaving contaminants such as virus, bacteria, heavy metals, aromatic hydrocarbons, pesticides, etc. Then third step is ultraviolet disinfection. After RO stage, the water is out, it is in a good quality. Then the last stage, what you do is you just put in ultraviolet disinfection, which inactivates last traces of bacteria and viruses. So this will produce highly pure water. So why we are putting reverse osmosis after this micro or ultrafiltration? So here the what like microfiltration, and here when you go for reverse osmosis, here reverse osmosis is having pores which is very very small, very small. So here you see the pore size here. If you see, the pore size is this much, and here when you come to reverse osmosis, pore size is less. So when we apply this higher pore size here, most of the bigger contaminants, higher sized contaminants more than this pore size will, we can separate. That is the first step that we are doing. So big sized foreign agents we are separating. Then when it comes to reverse osmosis, pores are very small. So here what it doing is small, very small sized these viruses, bacteria and heavy metals are separating in the next step. So that's why here first we are just separating the higher sized foreign particles. Then last stage is ultrafiltration, ultraviolet disinfection. Now you can just see through this new water and difference in new water, drinking water and potable water. Next step, next question. Israel recycles most of its sewage for four options are given. Options are groundwater recharge, augmenting domestic water supplies, C, agricultural reuse, and then industrial cooling towers. Israel recycles most of its sewage for, any idea? Answer is C, agricultural reuse. Actually, Israel is a very small country, and they are developing very high tech technologies in water treatment because their area is very dry area, semi or fully dried area. So that means that they need some technologies to produce water. They have a large number of desalination plants also. And then also they are, agriculture usage, they are recycling the sewage waste. And also you may heard of drip irrigation, right? Drip irrigation. So that I will, yes, here you can see in Israel. So you can see there are different types of, irrigations are there. Drip means how the way you apply the water. Also they put water like in, you know even this is like sprinkling water. For some of the crops this way is needed, this way. But in some of the crops for saving water, in the roots, near the roots, there the pipes are connected through, through all these rows. And then there is a small hole near the root, near the root of the plant, near the root. And then water will come like a drops. Then they ensure that proper enough water will go, the plant will get enough water, and the wastage of water is also less in this way. So they have more, efficiently, culture these type of drip agriculture lands. That they use this wastewater treated water that you can see. And I just given like in irrigation types they have adapted surface irrigation, and then sprinkler irrigation, drip irrigation, sub irrigation. So you can just read that. Then next one, usually the public acceptance of recycled treated sewage is highest for a portable uses, B. Bathing and washing clothes. C. Fish farming and food crop irrigation. D. Watering lawns and washing car. Most of public acceptance. Any idea? Yes. D. Yes. Watering lawns and car washing. For this, most people don't have much objections. Portable uses, we were not, that much okay with that. And also bathing and washing clothes, and fish farming and food crop irrigation, because many people think that when we apply waste treated water near the food crop, then when we consume the food from the crop, that will affect us. Okay, so then next question. Advanced treatment techniques used to treat wastewater for direct or indirect potable uses in New Water, Singapore, and Orange Country Water District, California include membrane bioreactors and advanced oxidation processes. B. Activated carbon adsorption and chlorination. C. Microfiltration, reverse osmosis, and UV disinfection. D. Membrane bioreactors, ozonation, and UV disinfection. Okay, the answer is yes, 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 yes. C only. C is the answer. Microfiltration, reverse osmosis, and UV disinfection. Yes. Next question. Zero liquid discharge policy as a mandate for gross polluting countries, industries ask for ensuring treatment and complete recycling of industrial effluents, only land disposal of wastewater, and no discharge to safe surface water bodies. See, shift to production of products which do not require water. D. All of the above. So ZLD for the polluting industries. It's mandatory. Why it is? Which option is more suitable? Yes, right. It's A. Ensuring treatment and complete recycling of industrial effluents. Okay. So here ISADLD we said zero liquid discharge. It is mandated for gross polluting industries. Why it is? It is ensuring treatment and complete recycling of industrial effluents. Then it is here the option B says only land disposal of wastewater and no discharge to surface or water bodies. So according to B option, land disposal of wastewater is fine, but it is not like that. Here land disposal of wastewater also pollute even groundwater. Also, if there is some rainy season is there, then that water will reach in the water bodies nearby also. So option B is wrong, and then shift to production of products which do not require water. So this option is also not right. So ensuring treatment and complete recycling of industrial effluences actually needed for polluting industries. Then next question. The water energy nexus considers four options are given: energy required for water and wastewater management, B. Water footprint of different energy production technologies, C. Both A and B, D. Neither A or nor B. The water energy nexus considers. What do you think? Any answer? So answer is yes, C is the right answer. So this here energy required for water and wastewater management, that is water energy nexus, and then water footprint of different energy production technology. How much water is how much water you are giving, or how much water it is producing. So here you can see the water energy nexus refers to it's an interdependent relationship between water and energy resources. This concept highlights how availability and management of water impact energy production and vice versa. So key aspects of water energy nexus you can refer: water for energy production, so then energy for water management, then resource scarcity, climate change impact, sustainability and efficiency, then integrated policies. So you can read about it and understand how the energy also comes in the water treatment. Then next question, which Indian city has planned to use recycling sewage for indirect portable reuse as a pilot model of Singapore New Water? So four options given: Bangalore, Kolkata, Jaipur, Visakhapatnam. What do you think? Which city is planned to use recycling sewage for indirect portable reuse? Any guess? Any guess? So the answer is A, Bangalore. Okay. Next question. Which is the correct statement about public acceptance of recycled wastewater? So, A. Older population are more accepting to reclaimed water uses. People with higher levels of education have higher level of acceptance of recycled water. See, religious people are willing to use recycled water than non-religious people. D. All the above statements are true. So, which is the correct statement about public acceptance of recycled wastewater? So, what do you think? Which option is right? Any guess? I think it's easy only. You can just. So, answer is okay. Answer is here B. Correct statement is B. People with higher levels of education have higher level of acceptance of recycled water. So when you become educated, then you feel like you know what exactly the process happening, and you can have have better clarity, and you can accept the recycled water. Then here option A, older population are more accepting. That is wrong. Older people don't accept this because they have they won't understand also. Even they can link with the religious things also for that. So most of the old people and religious people are not willing to use the recycled water. Okay. Okay, so any comments on till this questions? Sorry, sorry. 14. This one. This one. 14 is 1 4. 1 4. This one. Right? Fine. No? Okay. So we'll take 5 minutes break and come for we'll solve the questions from the activated slides. One problem we solve, and also yeah. Then I think remaining all the combined thing. Then I will give a small introduction to this membrane one. Today only, then next class I will cover from the starting the doubts, and also few things about the basic knowledge on this wastewater cycling recycling. Okay, so we'll take 5 minutes break. Okay, we'll start. So next, there is just one small note. What will be the wastewater activated sludge problems? So here I have just noted down, if you go for the activated sludge wastewater treatment, so what will be the crucial things or problems that we face? Nutrient deficiencies, overload of the system, growth of unwanted bacteria, too low or high mean cell residence time. So residence time is very critical, that we already noted down. And then sludge bulking, and then equipment problem. So these all things you can just note it down, like what is the important problems that we face when we run the activated sludge system. Next one is a problem. So so here it's a simple problem that we there is the data of an system is given. We have to find aeration period, food by mass ratio, then BOD removal efficiency. So we have to find three things. First one is aeration period. So you can note it down. So here in the system, see anything? Okay, just 1 minute. Now, now it's okay. So this one you can note it down. This one. Okay, then. So here the system is given, the important parameters it is given, and then we have to find the aeration period, food by mass ratio, BOD removal efficiency. So first of all, wastewater flow, Q is equal to, here it is 50,000 meter cube per day. Then volume of the aeration tank is given, and then influent BOD is given, then effluent BOD also given, then mixed liquid suspended solids 3000 milligram per liter, effluent suspended solids 40 milligram per liter, suspended solids in waste sludges 12,000 milligram per liter, and quantity of the waste sludges 250 meter cube per day. So now we have to first find out aeration period. Any idea how we find this? How do you find the aeration hours? V by, yes, right. So you can find out and tell the answer. V is 1000, 15,500 divided by 50,000. So here this is meter cube, and this is meter cube per day. Meter cube. So you get in day, you can convert in hours also. So how much you are getting day per day? I will calculate just. Okay, you get 0.31 day, right? Is it right? For this answer, 0.31 day. Yes. So then how do you convert into hours? 0.31 20. Okay. Into, okay, 7 point, okay, 7.44 4 hours. Okay. That is the answer for aeration period. And now second one is F by M ratio, food to microbe ratio. How do you calculate this one? Any idea? So from this given, then can you tell the formula? Let's say you just take this one as just y naught, and this is like ye. Just take like this, and then so here formula is q into y naught divided by v into x t. So that means q is the wastewater flow into y naught influent bod, and then v is the volume of the aeration tank, and then xt is the mls. So through this you can find the answer. You can start writing. So q is equal to 50,000 meter cube per day into y naught 200 milligram per liter, and then volume of the aeration tank 15,500 meter cube into xt mls is 3,000 milligram per liter. 50,000 into 200 divided by, what is the answer? Got is 0.215. This is actually, don't look into the units here. This one we have to write like kg, kg of this bod per day, per day per kg of MLSS. We have considered MLSS here. Okay, I will write in the next page. So here this answer what you got from F by M ratio through this Q into Y naught divided by V into XT. That is actually you got 0.215. This is kg BOD per day per kg of, because we got per day when we cut this all we got per day, but here you see kg and here denominator also kg only. So this unit conversion is there, kg of MLSS. Now uh, in the question you go, and then in question it is given MLSS 3000 that we considered, and when we analyze, because okay. Okay, this is like per kg of MLS that we found in F by M. So now, um, just leave for some space for this question, and next last question we will find. Then we come back. Last question is, what is the BOD removal efficiency? How do you calculate this? BOD removal efficiency. Okay. How do you calculate the BOD removal efficiency here? Sorry. Yes. Let's remove. Yes, influent BOD, then you have to subtract with the effluent BOD, then you have to divide with influent BOD. That is the percentage efficiency of BOD removal, right? See, BOD influent minus BOD effluent divided by BOD influent, right? Got it? Any confusion in this? 200. Sorry. So in that, what you're saying? Yes. 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 Okay. Sludge waste. Yes. No, it here in the booklet it is they haven't considered it. So that's why I just, yeah, just consider in simple way like influent minus effluent divided by BOD influent this way. The answer will come like 87.5 percentage. Any doubt in this? Sangamitra, like what you are saying, like in that way, like if you calculate what will be the answer, can you just tell me? If you consider the BOD which is in the pipe also. Yes. Q into, okay. Mhm. Here we here yes, yes, here the Q for the water flow, it is just a normal, it is taken like Q constant. Okay. So this is like, okay. Okay. Yes, yes. Okay, okay. So this, I think this question in the booklet, this way they have given. So I think it is just a normal, like just take Q as constant. So the numerator and denominator get cancelled. So we don't need to consider Q here. Just go for the BOD influent and effluent. Yes, yes. Yes, next week, Monday. I can't. Your voice is actually cutting out. Can you just. Okay, okay, okay. Sorry. Uh-huh. Okay, okay. Okay, okay, okay. You want the influent flow rate and the effluent flow rate is given. Then you have to find out the removal efficiency. Okay, okay. Yes, yes. I just note it down. Okay, influent flow rate so that Q on B cancel out and you should have the two Qs like that, right? Okay. Yes. Okay. Okay, I will take in the next class. Yeah, all the doubts will cover in the because 2 hours we get for the next class. That will be the last class. Next class. Okay. Okay. Hmm. Okay. Huh, yes. Which I have solved. That I don't know. Yeah, because I don't actually I don't have any idea, like because we have do not have any connection with the question papers and all. We are just like mm, assignment problem solving only. I don't know about the, you may got some previous year questions and all, right? That I don't know, but I will inquire. Like I actually don't have any idea like how the questions can come, but I hope that all the assignments, like I think you people are attending the other, like two people's class also, right? So I think I hope. Okay, okay, huh. Okay, I hope that within this, and then you can just read the, you get the transcripts also, right? The slide transcripts from the net. You can download, right? Even yes, the thing is, if you can't see the video, if you miss also, you if you feel that you have to see, you may have seen the video, but still, if you have the what sir has teaching, and if you have to look in side by side, you may download the transcripts also from site. Got it? Okay, I will just show you. Sorry. Okay, just I will just 1 minute. I will just open and show. Okay. Okay, see here. So you can download the assignments, and here this transcripts also you can download, right? This way. Have you tried? So see here, I will just show. So you can see all the videos from the classes, but you can't see every, repeatedly you can't find the. So I feel like it is easy that if you download this also, it's a kind of note. So this is the slides that the I think the professor cover. So then you can even look into these slides, because all the it's a script of the teaching material only, the videos. Even this you can use. Okay, so I feel this is more useful. You can see the video, but in some time you want to just see the notes. That time you can even see this slides. For all your lecture slide, this is available. Okay, you can take this also. Okay. Yes. Yes. Okay. That I actually. Mm-hmm. Okay, thank you. Huh. So actually, I don't have any idea on this also because and I am not correcting assignments and all. So uh, I think you guys can discuss on this. Okay, then I think the idea that I have given also you can see the videos and also you can download and keep the transcripts and prepare for your exam. Huh, that will be yeah, yeah, that is better. Yeah, yes, yes. Huh. Yes, yes, transcript. I feel like transcripts like just in video you don't know where when that part will come, but in transcript just you easily get it, and for your exam preparation you can use it. Okay, okay. Then next question, lower food to microorganism ratio in a conventional activated treatment plan will mean. So four options are given: lower BOD removal, higher BOD removal, no effect on BOD removal, for medium BOD removal. What do you think? Lower food by M ratio is lower. That means yes, right. Why it's so? Food is huh. Yes, then there are a lot of microbes. Then it will remove these. You know what in the food what we are giving the BOD it will degrade or it will convert. Then this is another problem. We can just solve it. This one, um, F by M ratio. So here also daily flow is given, and then average BOD of settled sewage is given, mixed liquor solids MLS is given, aeration basin volume is given. You have to calculate the F by M ratio. How do you calculate? If only these parameters are given, then how do you calculate with this data? BOD is given. Yes. Then MLSS into P. So here Q is given, and then BOD we have MLSS V. So from this you can calculate the F by M ratio. 19.2 million liter per day into BOD 125 milligram per liter divided by 2500 milligram per liter into oleum 8 8,000. It is like in meter cube. So in mill you can take 8, then milliliter. So then how do you what will be the final? 0.12. Okay. Let me also calculate. 0.2 into yes, right. 0.12. 0.12 you can write kg BOD divided by kg MLSS per day. Got it? Sangamitra, you also? Okay. So next class I will cover, I will write also like what are the things to cover. Problems in activated sludge with the different influent and effluent rate, right? Activated sludge process, and then I have to cover with Q influent and effluent. So any other? So you people also, okay. Which one? Different different treatment process. Micro. I mean this MBR, like that, MBBR, that all. Okay. Okay. Methods comparison. Then no, no, I haven't discussed. If you want, I will discuss in the next class. Phenol removal. Okay, phenol removal, like in different way of treatment, right? Okay, cocoa. Okay, coke. Okay, okay. I will discuss. Then these are. I think nothing else. Something. Then I think last few classes only this theory. I think that is fine. I guess simple only. I guess first if I think 1 to 10 weeks are little bit. I think more problems are there in that. Okay. Then briefly. mm, Okay. 1 to 10 week. Okay. Then enough, right? Anything else is there? Okay. 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 Then I will just today. I think I will just start with the few. Uh, what I can discuss is few basic things on water treatment. I just take for 10 minutes. Then we stop today's class. Uh, First of all, I'm just. It's a basic thing. Like it's for you your understanding. I'm telling. Uh, when you understand carbon footprint, I think it will be useful. This concept will be useful in your research time, and also you may heard of life cycle assessment. So life cycle assessment, so even in terms of water treatment plants, different any type of water treatment plants. Okay, in life cycle assessments. So here, um, I'm just giving a point, a simple point, not from we have to discuss on water treatment plants, but I'm just giving you a hint that whether is okay. I just give the fuel based cars, then electrically active electric cars. What we normally say, carbon, the emission from the electric cars are less, that we assume, right? We no, it is, uh, we will always tell this electric cars. Then for fossil fuel based cars, we say that there is lot of pollution, mainly air pollution, we say. So but when we really go for life cycle assessment, so have you guys have heard about this life cycle assessment? So this life cycle sorry, anyone? Sorry. Yeah, that will come, that is there. Also, it when it start to burn, like I mean, each and every part of electric cars, each and every part, it's tire, it's body parts, means it's a total metallic parts and engine. So even the engine, if you take each and every part in engine, how do you produce that, how do you, fabricate, how do you make that? So even when you fabricate that, how much pollution is happening? Pollution in each and every step, from each and every part of the car, how, from its starting from a minute point to the end of usage, and then end of the car, till that time how much pollution it is causing. When we analyze this pollution, that is the life cycle assessment of electric cars, you get to know even electric cars in us are also have a large amount of carbon footprint. That means it will emit carbon dioxide, it carbon monoxide, sulfur dioxide also. When you analyze the whole cycle of the electric cars, it is also not below for fuel based cars. So that you understand. So like that, when you come to the water treatment plants, when you analyze from the, very initial starting, you need the plan, the place for the water treatment plants. What do you do? If it has a lot of trees, you will cut down the trees. When you cut down the trees, there is a carbon footprint. So then you, what you do, like you have a transport, you have a transportation for the materials, raw materials to drop. So these raw materials, when you drop also, there is transportation of different vehicle. Even that vehicle will cause the air pollution. Like that, in the life cycle, these all things are counted. So that is like energy, the total energy requirement, that will considered from the initial, from the beginning. And then you come and then you build the plan. Then it will also, what you think, if you have even if you have any plan, it need electricity, right? Even if you're not directly using the electricity, indirect use of electricity is there for your whole plant. So that electricity, what you, even if you produce from that electricity from renewable sources, it's fine. Even from renewable sources also, if solar panels you are using, wind turbines you are using, how do you fabricate that wind turbines and solar panels? What is the amount of carbon that is emitted in the fabrication of solar panels or in the wind turbine? So these all things will come when you analyze a life cycle assessment of a whole, water treatment plant. So when you analyze that, what technology you feel that it is good? If you go for zero liquid discharge, it has different steps wise treatment steps. And this is the treatment steps, and after that also there is more disposal step. So Even before that, the maintenance view you can consider, and build of this building, raw materials. So even when you consider the whole, you understand that you can calculate the total energy, and from the energy you can even you can calculate the carbon emission. So from this carbon dioxide emission calculation, you can find out how our water treatment plant as a whole, how it is impacting our ecosystem, our environment. So this is just a small note that I have given, that it will be helpful for your future research. Okay, I think today we will stop. If any other doubt is there, then I will add here. Then next class we will discuss any more things, or we'll end the class for today. Any doubt in this today's class? Yes. So normally people always consider the running stage. How much? So people, if that RO plant is there, people say that the emission is less in the running period. But indirectly during the fabrication and all, there is a lot of emission is happening. If you go for life cycle assessment, you should consider. But if you are going separately, then you can just people for their marketing. If some big companies are there, they may tell like that. Yes, some in fruities, so in some juices and all, if you see in the pack that is like environment friendly, they have written, right? Have you seen? But in their real treatment, if you they consider the life cycle assessment, it is not true. But for their own benefit, many companies are just projecting that. That's all. But even when they use also, like, they are saying that, but even when that step now, then they take the used one, then they are recycling. In that step, there is a crucial emission is happening. If it's not happening, then it's fine. But in life cycle assessment, when you can even, you say that renewable energy, we will say that it is great, of course it is great in the running time. Then, but when you see, when you solar panels, so how do you fabricate panels? From the starting to end stage, you analyze that there is emission for the fabrication. Then after that, after this get damaged or you want to dispose, then how do you dispose, or how do you recycle? That stage also there is. But when you consider the life cycle assessment of any product, there is emission in one stage or another stage. In some of the companies will not project that, they just project where their emission is low. That's all. Yes. Okay. Any more doubts? No. Okay. Thank you. So can we stop today's class? Okay. 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 Thank you all. Thank you. Okay. Bye. Thank you. Thank you.